Hi guys, today we're going to be taking a look at the relationship between parallel and perpendicular lines and their equations. So when it comes to parallel lines, we know that parallel lines are lines that are heading in the same direction and never meet. So if we're looking at these two parallel lines here, I'm just going to find the slope of these two lines. So if I'm finding the slope of this line, remember, slope is equal to rise over run. So if I start at the point on the left, the rise is 2 and the run is 3. So that's the slope of that line. And if I'm taking a look at the second line, start at the point on the left to count the slope. And remember, you can use any 2 points on the line. It's got a rise of 2. And a run of 3. So parallel lines have the same slope. So if two lines are parallel, they have the same slope. We also know that that works in reverse order. If we know that two lines have the same slope, then we know that they're parallel. And we always talk about horizontal and vertical lines because they're kind of special lines. Horizontal lines are all going to be parallel to each other, and all vertical lines are going to be parallel to each other. So let's take a look at this example here. Give the equation of a line that's parallel to this line. So we know from this equation that the slope is equal to 5. So the slope of the line that's parallel to that is going to be the same. So I need to write the equation of a line that has a slope of 5. Remember, we're using y equals mx plus b here. So y equals 5x would be an example of a line that's parallel to y equals 5x minus 3. I could write y equals 5x plus 8. Any y-intercept I could add on to the end of that to make it parallel to y equals 5x minus 3. All right, now we'll take a look at perpendicular lines. So this is a little bit different situation here. Let's do the same thing we did before. We'll find the slope of these lines. Let's start with the green line here. So this line, same thing, we're counting the rise and the run from the left. So the slope of the green line is down to and over 3. And the slope of the red line it rises 3 and runs 2. So when you look at the two slopes of those lines, you notice that one is negative, one's positive, so they got the opposite sign. And you can see that the fraction has been flipped, and we call that the reciprocal. So the relationship between perpendicular slopes is that if two lines are perpendicular, they have slopes that are negative reciprocals. And another way to explain that is that the two slopes are flipped and the sign has been changed. So just like with parallel lines, we can say the opposite as well. If we have two lines and their slopes are negative reciprocals of each other, then we know that they're perpendicular. And if we talk about the relationship between horizontal and vertical lines, all horizontal lines are going to be perpendicular to vertical lines. Let's take a look at some examples of perpendicular lines here. So we're going to try and come up with an equation of a line that's perpendicular to this line. Now remember, for the slope of this line, there's a 1 underneath that negative 2. So that's the slope of that line is negative 2 over 1. So if we want the perpendicular slope to that line, we have to flip the 2 over 1 to 1 over 2, and we change it from negative to positive. So I need to write an equation of a line that has a slope of 1/2. So y equals 1/2 x minus 4 would be an equation of a line that's perpendicular to y equals negative 2x plus 6. Next one, give the equation of a line that's perpendicular to this equation here. So it's in standard form. So I need to find, so I can't pick out the slope like I can with the one in example 2. So I need to find the slope of 5x minus 6y plus 3 equals 0. There's a couple of ways I can do that. One way is I can rearrange that equation to solve for y. So right now I've got a negative 6y. I'm going to move it to the other side of the equal sign. So that becomes a plus 6y on the other side. And remember, I just want to solve for y here. I want to change this into slope y-intercept form. And when I bring the 6 over to the left side, I have to divide each term by 6. So I'm going to get 5 over 6x, and then plus 3 over 6 is going to end up being 1/2. So there's the equation in slope y-intercept form. So the slope of that line is 5 over 6. The perpendicular slope to that line is negative 6 over 5. So now I need to write the equation of a line that has negative 6 over 5 as its slope. So the negative 6 over 5 goes in front of the x. And then I just need to add a y-intercept on the end. So now taking a look at this one, give the equation of a line parallel to that line that passes through 5, negative 2. All right, so when we want to find the equation of a line, we need a slope and a point. We've got our point here. We don't have the slope. So I'm going to find slope of 7x minus 3y minus 6 equals 0. So I'm going to do the same thing I did before. I'm going to move the minus 3y to the other side, change it to plus 3y. And then I'm going to divide each term by 3. So minus 6 divided by 3 is going to be minus 2. So my slope is equal to 7 over 3. So my parallel slope is going to be 7 over 3 as well. Now I just want to show you the shortcut for finding the slope here as well. When the equation's in standard form, we've got ax plus by plus c equals 0. So our a is 7, our b is minus 3, our c is minus 6. I can find the slope of a line using this little formula here, which is m equals minus a over b. So if I use that here, a is 7, so minus a is going to be minus 7. B is a minus 3, that's what's in front of the y. And you can see that I get the same slope if I do it that way compared to rearranging the equation. So that's always an option there when you want to do that. All right, let's get back. I've got my slope. I've got my point, so remember that's my x1 and my y1. So I'll write my formula for finding the equation of a line using slope and a point, like we did yesterday. So this is going to be y subtract negative 2. So it's going to be y plus 2. My slope is 7 over 3. And then I've got x minus 5. I'm going to bring the 3 to the other side. So it's going to change from divide to multiply, and then I need to distribute these two guys inside the bracket. So I get 3y plus 6 equals 7x minus 35. And then when I rearrange the equation, I have 7x minus 3y. And when I bring the 6 over and it becomes minus 6, I'm going to end up with minus 41. So there's the equation of the line that's parallel to 7x minus 3y minus 6 equals 0, and it passes through the point 5, negative 2. All right, last example. Same situation as up above, except this time it's perpendicular, but I've got a point, and I don't have the slope. So first thing I have to do is find the slope of 9x plus 12y minus 4 equals 0. I'm going to use the shortcut that I showed you up above. So m is equal to minus a over b, so this is going to be minus 9 over 12. I can actually reduce that because they can both divide by 3. So there's the slope of the line we were given. We need the perpendicular slope. So remember, for the perpendicular slope, I need to flip that slope over and change it from a minus to a plus. So the slope I need to use is 4 over 3, and I'm going to use this point here. So now I'm back to my formula for the equation of a line with slope and a point. So it's going to be y plus 7, because I'm subtracting negative 7. Put in my slope. It's going to be x plus 6. I'll bring the 3 to the other side and multiply it. And then I'm going to distribute to clear the brackets. So 3y plus 21 equals 4x plus 24. And then I'll bring everything to one side. And I end up with 4x minus 3y plus 3 equals 0. Okay, we're going to practice this tomorrow in class. We'll see you then.